Hi, I'm Peter. In this tutorial I will show you the operation mode, in which DYNA4 is used as the execution master for your DYNA4 simulation. If you didn't watch the introduction by my colleague Susan to the joint usage of DYNA4 and Canoe, you may want to do this first. Otherwise, we are ready to go. Please start DYNA4 now, if you didn't do it already. We will use the Demo Studio project as the template for our DYNA4 and Canoe simulation project, because it has the fewest license requirements, but any DYNA4 project can be turned into a suitable Canoe simulation model. There are no specific requirements to the model. Please generate a Demo Studio project and use it as the template for your own simulation model. Just go to the File menu to create a new example project and select the Demo Studio project. Let's rename it to My Canoe Simulation and finish the dialog. Please open the newly generated project now. If you followed the tutorial with Canoe as the execution master before, you can reuse the project from before or choose a different name for a new project. First, we need to edit the Simulink model. So please start Matlab and open the Simulink model by clicking on the Simulink icon in the toolbar, if you didn't do it already. While Matlab starts, a small note about the Canoe Matlab interface. This interface is usually provided as an additional installer with Canoe, but DYNA4 automatically comes with a supported version, so you don't need to install anything additionally. Please go to the Simulink model, and add the DYNA4 Canoe interface block from the DYNA4 Simulink library to your model. These signals in the block trigger the Canoe measurement and are necessary for the synchronization. This is all we have to do to prepare the Simulink model for the execution in Canoe with DYNA4 as the execution master. If you followed the other tutorial in which Canoe serves as the execution master before, you can use the same model for this tutorial. However, the changes we did in the model in the other tutorial are not required when DYNA4 serves as the execution master. Enable the Canoe simulation target after clicking on the gear button, if you didn't do it already. Now you can build the NodeLayer DLL via the Build button in the simulation view. The build takes a while, but in the meantime, we can switch to Canoe. Please create a new default Canoe configuration. As long as you have no real buses configured, you have to select the simulated bus. Go to the configuration desktop and just add a new test CAPL node that has to be configured to use the NodeLayer DLL we built before. You can find the compiled model in Database, Models, Build, and the selected target, in our case, Vector Canoe. Choose the DLL that is named like your simulation model. Please save the new configuration, let's say, DYNA4 Execution Master. The Canoe configuration should be selected in DYNA4. If you don't do this explicitly, DYNA4 will use the currently open Canoe configuration. Please go back to DYNA4 Studio and click on the gear button and select the Canoe target in the navigation tree. In this dialog, you can select the Canoe configuration we generated before. As you probably noticed, we didn't do many changes to the Canoe default configuration. Therefore, this configuration is very generic and can be used for all simulation projects you prepare with DYNA4 as the execution master. After selecting the Canoe configuration in DYNA4, it will be used automatically when you execute a simulation from DYNA4 with Canoe as the simulation target. Please note that project-specific preferences allow you to select a different Canoe configuration for each DYNA4 simulation project. Now, we have to assign the parameters of the currently active scenario and model data to Canoe via RT download with this button. This will add the project-related files to the Canoe configuration via the Canoe API. If Canoe is not opened yet, it will automatically start your Canoe installation with the configuration we selected before. Now, all you have to do is to click on the Run Scenario Simulation button to execute the simulation. Instead of executing a single scenario, you can also use DYNA4's task automation by activating this switch in the simulation view. DYNA4 automatically starts the Canoe measurement, opens the animation and also stops the Canoe measurement. Now we only have one optional step left, in case you want to interact with specific signals of the DYNA4 model. You can add dedicated Canoe communication blocks to your DYNA4 model that are provided with the Canoe Matlab interface. I will show you an example of this with one output signal from DYNA4. First, you have to define the DYNA4 output variables in Canoe. Please go to Environment, System Variables and select New System Variable. Use, for example, the namespace DYNA4 output. Add a system variable with data type double, for example for the longitudinal acceleration of the vehicle. Save your Canoe configuration. Now that we have defined a new system variable, we have to generate the corresponding communication port in Simulink. Just add a bus selector and select the acceleration at the center of gravity. The acceleration is provided as a three-dimensional signal, so I'm adding a demux block to access the single directions, x, y, and z. Now, just connect the first signal with a Canoe system variable output block from the Canoe Simulink library. You can find them in the Simulink library browser in Vector Canoe, Canoe.io. Just drag and drop them into the Simulink model. The other two signals can be terminated. Double-clicking will open the configuration dialog. When you click on Select Variable, you can select any system variables from the active Canoe configuration. Please select the newly created system variable and save the Simulink model. Now that we made changes to the Simulink model, we need to rebuild it to generate a new DLL. Just hit the Build button again to overwrite the DLL we generated before. Now, when we go back to Canoe and add the system variable to the data window, we can see the current acceleration in Canoe. You can do this similarly with other input and output signals. After the build procedure is completed, you can hit the Run button again. Now, we can see the values of the acceleration in the data window. That's it from my side. I hope I could give you some useful insights on how to couple the vector tools DYNA4 and Canoe.
Thanks for this hands-on introduction, Peter. You now got a deeper insight into how DYNA4 and Canoe can be coupled with DYNA4 as the execution master. If you are interested, you may want to watch our other tutorial in which Peter explains how Canoe can be used as the execution master. Like in this tutorial, Peter will explain how a DYNA4 simulation model is prepared from scratch for the usage with Canoe, so you don't miss any of the important steps. However, DYNA4 is also shipped with an example project called Demo Canoe Interfacing. This project contains Canoe configurations for both execution modes as well and is ready for execution without any further preparation. We hope you enjoyed this tutorial video and that you feel prepared to start your own projects in DYNA4 for the usage with Canoe. If you have any further questions, don't hesitate to contact us. Thank you for your attention.